So hello everyone, my name is Chen Xing and today I'll talk about the rate of change in calculus and vector. So let's begin. So now I have a graph. So first I name this point P and this point Q. And now let's draw its tangent line and the secant line between point P and Q. So now let's analyze their relationship. First of all, as you see, I can name the point P A F X A and then point Q A plus H F A plus H. So now we can analyze that the distance between point P and point Q is the absolute value of H. So let's begin to define the formula for the limit in order to calculate the slope. So first, limit equal, and as we learn in advanced function that the formula for calculate slope is y2 minus y1 and x2 minus x1. But now we are doing the limit stuff, so let's make some change. So first, I can say that this is f a, which is the part of the point P, and this is also the part of the point P, so it's A, and this is part of point Q, so which is F A plus H, and this is A plus H. So now let's make this formula more clear. So now FA plus H minus A over A plus H minus A. So now this is the basics idea of our limits formula. And now let's do some very hard, extremely hard, complicated calculations in order to make this formula become the real formula for limits in order to calculate the slope. So that's, and now so this is the formula for limit and in order to calculate the slope. So now we have discovered the formula for limit in order to calculate the slope. So before we moving on to this example, let me first introduce some basic idea of the limit. So first, for limits to be exist, there's two type of slope, preceding and following. For preceding, the Q is at front of the P, and for falling, the Q is at back of the P. And when the limit exists, both sides of the slope while approaching to the slope of point P. So when it happens, the limit exists, but when it is not happened, the limit doesn't exist. So let's see how this formula will show us whether it exists or not. And as you see, when this is preceding part, and when the edge is 1.5 away from point 8, the slope is negative 0.5. So let's make the number approaching to the point A. And as you see, while I approaching, the slope is decreasing. It keeps decreasing to 0.99. So remember this slope. This slope is slope of the preceding. Now let's do following. So ascend as preceding. Following is 1.5 away from the point A and its opposite side. So now the slope is negative 3.5. Let's make it approaching to A. And it keeps increasing to negative 2.1. And as you see, the preceding is negative 1.99 and for it is negative 2.1. So which just means both are approaching to 2, and the 2 is the slope of that point, that tangent line. So now we can say that this limit exists. So now moving on to the next functions, and as you see here, this function's formula is f(x) equal to x squared when x is not equal to 3, and when x is equal to 3 it is at point 3.2. So which means when x is equal to 2, y is equal when x is equal to 3, y is equal to 2. So let's see. Let's put those numbers into our new formula. First, let us calculate the preceding and following point on when x is 3. So let's see. So first, see it here. This is the formula that have been plugging the number. So when it is following, so when it is following, when h is 1.5 away from 3, the slope is 1.5, and as it approaching it, at the end the limit is 0.01. So this is following, and let's see the preceding. So at first it is 1.5 away from the point 3, and as it approaching it, so at the end the slope is negative 0.01, which is means both of them are approaching to 0. But here is a question that the slope of this function is 0, but how about the other? So let's see. Let's move a little bit, maybe 2.99, I suppose. So now let's see the difference. Oh. Okay, let's do some. So now let's move it. So now let's move it to 2.9, and as you see, the slope is 4.3. This is totally different to the slope when the a is equal to 3. So let's see the changes. So when it approaches at preceding part, the slope is 5.79 for preceding. And how about for following? For following, the slope is 5.81. So which is means at this point they both are approaching to 5.8. But here's the question: is 5.8 close to 0? Definitely not. And let's see what other size is. Let's see. So 0.5 away from 3. How about this? So at the following is 6.09, and that's preceding. So at preceding is 6.09, and at following is 6.11. So which is means those are approaching to 9.1. So now, as a conclusion of this example, we find out that both sides, preceding and following, are not approaching to 0, which is the slope of the point P. So now we can say that this example, in this example, the limit doesn't exist at point 3. The slope of preceding and following are not approaching to 0. So it's a if section.
So overall, thank you for your watching and hope you have a nice time watching it. But yeah, I don't feel like. But overall, thank you for your watching. Hope you have a nice day.